Welcome to the Joy of Coding.
Hello and welcome to episode 40 of The Joy of Coding. My name is Mike Conley. We got a great show planned for you today. We're going to be hacking on Firefox stuff. We're going to be fixing some patches and exploring some stuff. I'm really excited. So let's take a look at the agenda. Whoop. Okay, so this is the agenda. It's January 13th, 2016, and I say this every time, but I do it for the new people who might be joining this video or watching the series. There's an agenda, sort of. I mean, it says right at the top that no plan survives breakfast, and that's true because while I have a vague sense of where I want to go, I don't actually have like a script of how I'm going to get there. So things might go wrong. But if you want to get a copy of this agenda, which has useful links and stuff, especially if you want to follow along in what I'm doing, if you look down below, there's an additional link section if you're watching this video on Air Mozilla, and there'll be a link to the agenda there. Or if you're watching this on YouTube, there's probably something in the description section. If you're watching this on my blog, it's probably either above or below this video, and you can click on that, and that will take you to the agenda. So, what are we doing today? So the first thing I want to do is I want to fix up a patch I've been working on. I got some review feedback and I fixed some test failures with it, and I want to just fix up that last bit of review feedback and then post it up for review again. And that's for getting rid of a session history kapow, and I'll talk about that in a bit. After that, I want to try a new segment. I don't know if this is going to work, but I'm calling it for now Better Know a Gecko, kind of based off of Stephen Colbert when he had the Colbert Report, did this like Better Know a District, where he talked about various obscure districts within the United States of America. And I kind of wanted to do the same thing, but for regions of Gecko. Basically, like find a region of code that I'm unfamiliar with, and then explore it with you in the side by side. We can go check it out together. And I'd take notes while I sorted it out and tried to figure out what was happening. So I'm going to take a look at the async tab switcher today, which I'm sort of familiar with, but I wouldn't say I know it really, really well, and I want to walk you through it and walk myself through it so I can get a better sense of it. And I have another bug here, if we get to it, where I want to make profile dumping work more better. That's not right. Work better for E10S, which is one of my quarterly goals. We had done some work on that a couple weeks back, and maybe we'll get back to it today. But I wanted to try this Better Know a Gecko thing first, just to see what you think. Because if you like it, or if you don't like it, I want to hear about it, and that's another thing I want to talk about. I'm now starting this thing where for every episode, you can rate the episode. So there's a Google form link right here. If you click on this, you can tell me what you thought. If you liked Better Know a Gecko, let me know. If you didn't like Better Know a Gecko, let me know. If there's a different piece of code you'd like me to explore with Better Know a Gecko, let me know, and I'll queue it up. This is for you, so let's make it work. Okay, so let's get started with the work.
Here we go!
So I've got my patches all. I know it's kind of my repository is a bit of a mess. I just did a rebase of that profile stuff, just in case we got to it. But these are the patches I'm talking about, and it was hairier than I thought because it turns out that there are a bunch of add-ons that use this kapow, and so I had to shim it. I had to add a shim. We have this layer that allows us to basically make it seem to add-ons like certain things are where they expect them to be, to pretend like if an add-on says get me the session history object, we'll go okay and we'll give it to it transparently, but only for add-ons. If anyone else tried to do that, like in the browser code, if they tried to access the session history object in the parent process, we'd say you can't do that, you need to access that in the content process. So this is part of the shimming layer. Yeah, I added some shims. And if you're interested in checking out those patches, I've actually posted some for review and I've already got feedback. So this is the bug. Oh, I've already got it open. this is the bug, and I got review from Gabor on one of the patches. I'm waiting for review from Felipe on another one, but some feedback came in from Gabor that I want to address. He says he gives it r equals me. That's his way of saying yes, you can land this if any of my suggestions work for the target.wrapped.js object line. If I misinterpreted that line or you want to do it differently, please let me know. If is this the case that we're in non-ETNS mode? The funny, I mean horrible thing about wrap.js object that is used for these double reflected objects, but also for X-ray wrappers. So this code might just waive the X-ray wrapper. So this code might just waive the X-ray wrapper for a native web navigation object. So instead, use an instance of, which might not be easy because scopes, or check the class ID. Check if E10S is on or off. Alright, he doesn't like the fact that I'm checking the wrapped.js object, which I can understand. So I got a lot of files open here. Let me check out the commit that he's talking about. Also, if you want to talk to me, if you have questions while I'm doing this, we're in the #live hacking IRC channel. And I want to hear from you. Say hello. So remote add-ons parent. I've added a couple of shims here. Where did I add a shim for session history? And this is off of the web navigation object off of a remote browser. And that's a lot of jargon. But basically, this is the object that you use to navigate the browser, under the hood. All of when you click forward or you click back or you type a URL and press enter, the commands that are navigating that browser object somewhere is using the web navigation interface to do it. And for E10S, we have what's called the remote web navigator, or remote web navigation, which sends messages. It implements the interface and sends messages down to the content process to do the work. And there's this part of the interface that exposes the session history, which you can't do in the parent process unless you do it with a kapow, because the session history is something that only the content process and the doc shell and the content process knows about. And so I've removed that kapow, but now I'm shimming it. That's sort of the story. So this is the remote web navigation interposition, and I'm adding a session history getter interposition. This is all quite complicated stuff, and I don't fully understand it myself, but if you're interested in reading up on it, remote add-ons parent.jsm is the file you are looking for. And this is the problem, this is the part that he has issue with. So target, in this case, is going to be the thing that we're attempting to get the session history on. And in this case, it's going to be what I hope to be a remote web navigation interposition, or remote web navigation object. But if you look at the way I defined the remote web navigation object, all I've done is said that anything that's an NSI web navigation, we're going to hook it with our interposition for add-ons with this session history thing. So it's possible that for the non-remote browser case, we are still going to, if an add-on attempts to access the session history object, we're going to enter this block, this interposition. And we want to be able to just return the actual session history in that case and not replace it with our doc shell session history kapow thing that we're doing down here. So the way I'm detecting whether or not the browser is remote or not remote is I'm not actually looking at the browser. I'm looking at the remote web navigation, or the web navigation object itself, and seeing if it has a wrapped.js object. Because in the implementation of remote web navigation, which is way down here, I think. Whoop. I set this .wrap.js object to this, which allows me to get, that's like some XPCOM magic that allows me to get under the hood of something that represents an XPCOM interface to the actual object itself. Which you're really not supposed to do, but we do it all the time. Because sometimes we need to access those things. and you want to access those things without creating a new interface to access those things, because we want to decomtanify things. Okay, so where was I? I've got so many open files. You know, the first thing I'm actually going to do is close a bunch of these files, because this isn't just, there's too many. There's too many files open, and I can't deal with this, so I'm going to close a bunch of stuff. I don't need this either. I don't need this. I don't need this information. Or any, I don't need that. Don't need this. Don't need either of them. Don't save. Don't save. There's, okay, that's quite a few we've gotten rid of. I'm going to get rid of, like, pretty much the rest of them. I know there was some stuff in there I still want, but it's easy for me to reopen them. And I don't need package manifest either. I'll get rid of multi-process shims. I could close them all. And then we'll go to remote web navigation. That's the one I want. And I also want remote add-ons parent.jsm. And in here, we're talking about his session history. Now, what he's saying, what Gabber is saying, is that this check here that I'm doing to see whether or not the web navigation thing is a remote web navigation or not isn't correct. Or he's worried that it's not, because wrap.js object might be defined on the standard NSI web navigation object, because of the fact that we overload wrapped.js objects sometimes, which is horrible. So he's saying maybe make this check different. So let's try and I like the idea of checking the class ID, because checking if e10s is on or off isn't going to be perfect, because e10s can be on and we can still have non-remote browsers. So let's see if we can do this class ID thing. Now, I've never done a class ID comparison before, but I'm pretty sure I can just, like, if I get at an XPCOM interface, what's a good one? Doc shell, content, selected browser dot doc shell. Class ID? How do I get the class ID? That DXR class ID. Oh, if I can get it off the prototype.class ID. Oh, whoops, I need to choose a different browser. G browser, selected browser. Doc shell. Prototype. There is no prototype. What else is in here? It's big business. Proto __ proto. But I don't see, like, class ID. No, I don't see that. I need to find a place where we check the class ID. In JavaScript. I'll do dot class ID. Maybe I can use the component registrar to get the class ID. Register, auto unregister, register factory, enumerate things. How about XP.com utils? Will that give me what I want? Class info. I see like usage of components.id all over the place. And then there's this like browser. Huh. I wonder if I have to class ID ext IDL. Read only. Interface of object returned by components constructor. There's the class ID. So I wonder, well, class info. Maybe that's what I want. Provides information about a specific implementation class. If you want your class to implement NSI class info, get interfaces. This is not very compelling. I can make it implement this class info interface in the remote case, but then I've got like all of these things I need to implement as well. I don't think that's what I want to do. I could make it implement this NSI XP constructor interface. Does anything else give a class ID? Or a CID? Component manager. I think I looked in here, but I'll look again. Get. Ooh. Oh. Get class object by contract ID. Create instance by contract ID. These are all the wrong things. So how can I make it obvious that this thing, like, can I get somehow access to the contract ID? Path IDL or next IDL from class info again. Might have to ask for help here, which is not, there's nothing wrong with asking for help, but I thought I'd be able to figure this out pretty easily. I thought you could just get at the contract ID. No. I suspect not. Shoot. So what am I going to do? Is Gabor around? Can I talk to him? I'm going to ping him. in IRC, and we'll see what he has to say.
I can't do my work.
That's too bad. Class description. Where was class description used? Is it used anywhere? Only if you have access to the prototype. Or if you implement NSI class info. Components interfaces. Check. Okay. Query interface, the class info. Like, is there anything that the other web navigation? I guess if the other one is a doc shell, like we can do it the other way around. We can see whether or not the target, we could do it this way. If target instance of CI/NSI doc shell, we must have a non-remote browser, so we can go ahead. This will probably work. We can go ahead and just return the real session history. Return target.session history. Otherwise, this impl. If not target.wrapped JS object, impl equals target.wrapped JS object. If not impl, return null. That might do it. That might do it. You know what? I'm okay with this. Because, yeah, the doc shell, if I remember correctly, if I remember my doc shell stuff, this thing implements NSI web navigation. Yes, it does. And that's what normally you talk to in single process Firefox whenever you want to navigate a non-remote browser. It also implements NSI doc shell. Haha. So we may have done it the other way around. Instead of identifying, I'm going to unping Gabor. I'm pretty happy with this. Let's, what am I going to do? I'm going to commit that. Commit amend that. Where am I? Where am I? It's so hard. I'm right here. Add remote web navigation session history shim. I'm going to rebase this on top of it. Okay, commit amend. She evolve. And then I'm going to run some tests. Huh. It's weird. I have this like ESLint thing and it's not liking. Is my version of. Yes, I'm running too old a version of Node. help VM current nvm use 4. Is it 4.0.5? What do I have? Yesterday I downloaded the latest node, and it was 4.2.4. And nvm, can I make that like the default? Set default node version on a shell. nvm alias default 4.2.4. Yes, sounds good. So now that's good. And what were the tests I want to run? There are two. One exercises the remote web navigation stuff. Moki tests, toolkit components, remote browser utils, tests. We'll run that. And then there was a test that accessed. Oh, and I should also run this. This is the other test. Run this without --e10s, because that will tell me whether or not we can access the session history object in the single process case. So it passed. These errors are from the dummy page that we're loading. Probably should fix that, but in the single process case, hey, all passed. That's good. Now I want to make sure that I'm actually exercising the stuff I want to, that I wrote. So I'm gonna have it. I'm gonna have it like say something. I'm gonna have it like go, oh hi there. Build faster. This might be just as good. You know what? Build faster probably would have been faster. I just want to see if we're gonna hit that shim. I think we will. Yes, we are. Oh, hi. Oh, hi. Good, 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 good. All is going according to plan. So what I'm going to do now is I'm going to post this up for review. These 4 patches, HG push R, that to tip to review. I have some leftover spinach here from lunch. I hate this bug. It thinks that there are multiple heads, even though the range I selected, there are not multiple heads. Evolve A. Evolve divergent. Evolve any. Evolve does not work in that case. Rebase one. History rebase dest. What is that? P28, the parent of that to this. So one way to get around this that I've found is to pull and rebase. I don't know what the dealio is though. I ran into that yesterday too, and I don't know why. The range that I selected didn't have any branches coming off of it, so I don't know what the problem is. Come on, come on, come on. All right. Push R 320 183 to tip review. And I just realized I'm not plugged in to the power outlet. Let me do that now before I run out of power. There we go. Submitting forward changes to review. Oh. And the my sounds. Hang on. Hang on. What? Well, I'm playing What Happens, and
It's me, Mario.
Hey, what happened?
even better. All right, that's what I wanted. I just wanted to play a couple sounds there. I don't want to publish these right away. What I'd rather do is look at them first. Let's just do a quick self-inspection. Hey, new awesome skin for Mozerview. Pretty happy about that. So the first thing that I did was, yeah, I registered remote web navigation as a traditional XP-COM component. And I'm happy about that. Happy about that. I'm fine with that. Fine with that. Oh, yeah, okay. Yes. Yes. Now, I seem to recall, yeah, that's what I needed here. Good. Good, good, good. So that one I feel happy about. I felt pretty good about this one too. This is just getting rid of the, making it so that we don't even send up the kapow. This is making it so people in the browser, like browser developers, can access session history in the parent. Even though add-ons will be able to. This is the shim thing that I added that's now going to be checking doc shell. And then over here, I refactor a little. And I use get session history here, get session history there, and get session history there. I put that there because of why? Because get content documents right there. All right. So I feel pretty good about that. And so what I'm going to do is push these to try. That's what I want to do. I want to push these to try and see what the internet thinks. Not the internet. See what our test infrastructure thinks. Now they all exploded before because I forgot that whenever you add an XP-COM component, you can't just, you have to update the installer manifest and like all this old garbage that I don't remember having to do before, but there you go. Apparently I can't trigger try build on a draft. This should all get a lot faster soon. The Moz Review team's working hard on that. Instance of the target to NSI doc shell. If it resolves to true, I guess I know that we're looking at an in-process browser. Sound good? Publish. And okay, now I can trigger a try build. I send to all these tests. Ba-boom! Try build is Autoland is it is boiling in here. I'm sorry. I just realized it is. This is way too hot. I'm gonna open the door a little bit. Excuse me a second. I can feel the heat just like coming off the screen. It's the middle of January and it is boiling in here. Probably overcompensating with the heaters. Okay. Okay. So that's done. That's what I wanted to do there. Good work, everybody. So this part is done. The next thing I wanted to do was try this Better Know a Gecko segment.
Ow, wow, 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 wow.
Ow, as in, yeah. Ow! I guess from the Michael Jackson era. Better Know a Gecko. And the thing I wanted to look at was the async tab switcher. Now I'm thinking maybe we can look at this for 20 minutes to half an hour, something like that, and maybe we can spend the last half hour looking at this profile dumping thing. So while I'm waiting for, while I'm doing the analysis, what I'll do is I'll actually check out the patch over here, and I'm going to build it. And we can look at this code. Okay, so this is the E10S asynchronous tab switcher, and I've got some notes. There's a link to the notes here. Here are my notes that I'll be writing to. Let's see. The tab switcher is responsible. So here's the first bit. The tab switcher, well, maybe I should give you some context first. This is an E10S window, and these are tabs up here, you know that. And these are tab, like in browser engineer parlance, these down here, these things that change, the content that's being changed down here, these are the tab panels, and these are the tabs up here. This is the tab strip. Inside the tab strip are tabs, and when I click on a tab, the tab panel changes. Notice that the toolbox doesn't, or the toolbar doesn't change. Like it will update sort of. Bits of it will update, like the URL bar, for example. But if you think of it in terms of just like rectangles, when I click on this rectangle here, up here, this rectangle down here, I click this rectangle here, and this rectangle changes. I click this rectangle up here, and this whole big rectangle changes. I mean, that's changing tabs. And each of these big rectangles is called a tab panel. That's what you need to know. And a tab panel in E10S, the content that it's displaying is rendered out of process. Now, I'm about to try and explain kind of how this works, and I might have it a little bit wrong and imprecise, but I'm pretty sure this is the case. When you have E10S enabled, and you have a content process running outside of the parent process, all of the painting and stuff that's going on inside that content process will occur like without the parent even knowing about it. The parent doesn't have to worry about the painting because the child's doing all the painting. What the parent needs to know about is compositing. And there's a difference between compositing and painting. So what's the difference between compositing and painting? So when all this stuff, like suppose I'm looking at some website like this Node.js website, and there's like multiple steps that that take place whenever you have incoming HTML, CSS, JavaScript executing, and then you somehow have to get to pixels on the screen. And first steps like the networking, you got to get all that stuff downloaded, and then you have to execute it. And so your HTML parser is going to look at the HTML and it's going to render it, and layout's going to get a copy, layout's going to figure out how everything needs to be sized based on the CSS rules that also got loaded, and then JavaScript might do some stuff that changes certain styles and you cause reflows, and like eventually things settle down, and eventually we decide we have to paint. And what that means is a part of Gecko says, look, I have to show the user something. Can you just tell me where everything is, and I'll figure out how to paint it. So layout says, okay, here's where everything is. Here's the size of everything. That's what layout does, positioning and sizing of things. And then it says, this is the layout tree. This is how things are laid out. And painting goes, okay. Now what I'm going to do is, based on the things and how they're laid out, and how much of the screen is being shown, I think, it's going to go ahead and figure out how the pixels need to be rendered, like based on the CSS rules and the styling, and it's going to figure out how to color each dot in, and that's the painting step. And the content process will do that in E10S, and that's great because it takes a lot of the processing out of the parent. Whenever the content process is done painting, what it's got is what we will refer to as a layer. And that's basically just, it's got this. It's got this rectangle, this big rectangle. And what it'll do is it will write the pixels into a shared memory buffer between the parent process and the content process. So there's this shared memory region where the content process just blasts all those pixels down. And then, I hope I've got this right, the parent process receives a notification that these pixels were all written. And then what it will do is it will send, I think it's the compositor thread will notice that that those pixels were written, and then it will composite everything, including the browser, toolbar, and all the buttons and the Windows stuff together into the pixels that end up going to the graphics card. The graphics card, assuming you're doing like hardware accelerated graphics. If you're not, it'll go to the software. We have like a software graphics card thing, and you just send the pixels there, and we do the right thing to render it, but more slowly. So those are the vague steps. There's the painting and the content process. The parent will hear whenever the frame is ready, and then it will composite it all together. And by composite, I mean just sort of like put things like, it'll like transform things very slightly, maybe, like it will put the frame from the child down this number of pixels until it's under the tab strip, and it will put the tab strip above it. Like it'll just it'll think of it like bits of a magazine cover, and the cover photograph has come in from the content process, and now the compositing step is like putting the text on top and like all the stuff that needs to go on top. I mean, you've done all of the photography work and all the airbrushing you need to do on the magazine cover, and now it's just, and all of the fonts and stuff are printed, and they're on these like transparent cellophane sheets, and you just lay it all out. That laying it all out and saying done, that's the compositing process. And the compositing occurs in the main process in a separate thread. Off main thread compositing is what it's called, and that was a big project that the graphics team worked on way back in the day, and it works. It works pretty well. It takes the compositing step off of the main thread, and that's good for responsiveness. So why did I explain all of that? Well, in order to understand how complicated this switcher is, I think we need to understand why it needs to be that complicated. And it's because of the fact that whenever you click on these tabs, we're making demands on the content process to like give us frames, give us that layer for the web content for this tab that I've asked for, so that I can composite it. And then if we switch tabs while we're still waiting for that layer to come up, like we've got this sort of in-flight request still happening, and what do we do whenever the content process like responds with the message saying, okay, here's that original frame you asked for. Like all this business needs to occur, and that's why I think this thing is so complicated. So now that we have that context, let us read the comment, because there's a big comment block at the top, and that's usually a good and a bad sign. It's a good sign because it means that the developer was conscientious enough to comment it, and so that means that they're probably conscientious enough to comment the really hard bits and talk about the really sort of the things that you really need to know, hopefully. The bad news is it was so complicated that they needed to comment it and document it, especially if it's this much. So, pluses and minuses. Let's see what the comment says. The comment says, the tab switcher is responsible for asynchronously switching tabs in H&S. It waits until the new tab is ready, like the layer tree is available, before switching to it. So the layer tree is, I guess, I'm using different terminology all over the place. Like a frame is ready, a layer is ready. Excuse me. And in this case, this comment is using layer tree. And I guess that would make sense in the from the perspective of the content process, because the content process does know about like the way things are layered, but I'm pretty sure it's just coming up with a single layer. So the fact that it's a tree, I'm not sure if we need to say it's a tree here. But okay. The tab switcher is a state machine. So for each tab, it maintains state. So for each one of these tabs up here, it's going to keep a list of whether or not the layer tree is available, being loaded, being unloaded, or is unavailable. There's another thing I need to point out. This tab switcher that we're talking about here only exists for a short window of time, or hopefully for a short window of time. And that window of time is between the time that you start a tab switch and when the tab switch succeeds. After the tab switch succeeds, the switcher goes away. Or it should go away anyways. No, hold on. It's between the point where you initiate a tab switch, the tab switch succeeds, and all of the other tabs that you may have switched to before you got a success have have settled down, because they might have sent up their frames, or we might have sent down a message saying, hey, get rid of your frame and stuff like that. And we wait until all that settles down, and then it's destroyed. Okay, so it's a state machine. The switcher object is created upon tab switch. It is released when there are no pending tabs to load or unload. So, the following general principles have guided the design. We only request one layer tree at a time. Right. So that means if you like hit and hold Control Tab, so you're switching through a bunch of tabs. We used to just like ask the content process for every single layer tree for every tab that we were switching to, but now we'll just ask for the first one, and then we'll wait until we hear back, and then if in the meantime you switch to a different tab, then we'll send a message saying, okay, well now give me the frame tree for that one, and then we'll hear back. So if the user switches to a different tab while waiting, we don't request a new layer tree until the old tab has loaded or timed out. If loading the layers for a tab times out, we show the spinner and possibly request the layer tree for another tab if the user has requested one. We discard layer trees on a delay. That way, if the user is switching among the same tabs frequently, we don't continually load the same tabs. So that's, I think, that's a caching scheme. Okay, it's important that we always show either the spinner or a tab whose layers are available. Otherwise, the compositor will draw an entirely black frame, which is very jarring. To ensure this never happens, we do the following. When switching away from a tab, we assume the old tab might still be drawn until a Moz After Paint event occurs. Because layout and compositing happen asynchronously, we don't have any other way of knowing when the switch actually takes place. Therefore, we don't unload the old tab until the next Moz After Paint event. Right. Suppose that the user switches from tab A to B and then back to A. Suppose then that we ask for tab A's layers to be unloaded via message M1 after the first switch and then request them again via message M2 once the second switch happens. Both loading and unloading of layers happens asynchronously, and this can cause problems. It's possible that the content process publishes one last layer tree before M1 is received. The parent process doesn't know that this layer tree was published before M1 and not after M2, so it will display the tab. However, once M1 arrives, the content process will destroy the layer tree for A, and now we will display black for it. To counter this problem, we keep tab A in a separate unloading state until the layer tree is actually dropped in the compositor thread. While the tab is in the unloading state, we're not allowed to request layers for it. Once the layers are dropped in the compositor, an event will fire and we will transition the tab to the unloaded state. Then we are free to request the tab's layers again. So that sounds like the caching business. Okay, so that's the big comment. All right, that gives us a sense of what we're dealing with. So what we've got here on this tab browser XBL binding, we have this underscore switcher thing that is null to begin with, and then we have a get switcher method. And the first thing it does, it checks to see if there is a underscore switcher. And if there is, well, we'll just return it. So we memoize the switcher for the entirety of its lifetime, and then whenever, I'm guessing, it goes away, switcher will be destroyed and we'll instantiate a new one. Okay, I understand that pattern. Now we define the switcher. This is the case where we didn't have one before, so we define a new switcher. So we have all these things. For example, we have the tab switch timeout is 400 milliseconds, and that's how long we will wait for tab layers to load. So that's how long we'll wait until we'll show the spinner, basically. The next one is the unload delay. When the user hasn't switched tabs for this long, unload layers for all tabs that aren't in use. Okay. So if the user is just sort of like eased up, then we can tell the compositor thread, all right, you can get rid of those old tabs. The next three tabs form the principal state variables. See the assertions and post actions for their invariants. So 1, tab the user requested most recently. It's the requested tab. There's the tab we're currently trying to load. It's the loading tab. Then we have the last visible tab. This is the tab that we show this tab in case the requested tab hasn't loaded yet. Okay. This is the last tab that was visible if the switcher was still alive at the time of another tab switch. Okay. Because that might not be the requested tab. Visible tab, that's the tab that's on the screen. Last visible tab and visible tab. Okay. We have the spinner tab, which is null, the tab showing the spinner. We have the original tab, the tab that we started on. All right. And then we have a reference to the tab browser. We have the tab switch timeout timer. We have the unload delay timer. And then we have a map, which maps tabs to their states. True if we're in the midst of switching tabs. If we're in the midst of switching tabs, then we have this like switch in progress state. So much state. We also keep an whoops, didn't mean to go back. Keep an exact list of content processes, that's the tab parent, in which we're actively suppressing the display port. This gives a robust way to make sure we don't forget to unsuppress. Interesting. Actively suppressing the display port. A set of tabs that might be visible right now. We maintain this set because we can't be sure when a tab is actually drawn. A tab is added to this set when we ask to make it visible. All tabs but the most recently shown tab are removed from the set upon Moz After Paint. So here's another set that might be visible. And then we have all these state variables and a reentrancy guard. Okay, and now we're getting into the guts of this thing. We have a bunch of methods: get tab state, set tab state, init, destroy, finish, update display. Excuse me. So the one that I know that we enter first, or like after we define all that stuff, then we set the underscore switcher to the switcher, then we init the switcher. So init is the first thing that runs. Let's take a look at that. Init. And init is going to, there's a logging mechanism inside here, that's good, and then it will add event listeners for Moz after paint, Moz layer tree ready, Moz layer tree cleared, and then a tab remoteness change. And then it sets the tab state for the requested tab to this dot state loaded. Interesting. The requested tab, which starts out as the selected tab. Okay. And we assume that if the switcher wasn't still alive, then the first tab must be loaded. Okay. And then I know that the tab switching code will call request tab when it's time to choose a tab. Called when the user asks to switch to a given tab. This is like the main entry point. Everything else is all internal, but this is the entry point. And so let's check it out. If the tab that we're requesting is the one we're already showing, then we just return early. Otherwise, we have this instrumentation to figure out bug 116351. Oh yeah, we have this like weird bug. And we don't have good STR, and so I added all this instrumentation. And you know what? I've never heard a thing. I've never heard a thing. I don't think this stuff is ever going to report anything useful. Okay, then we log the state of the tab that we're requesting, and then we start the tab switch. Now start tab switch starts like we set this telemetry stopwatch, we cancel one that may have been started before, and we start a new one. We add a marker, and then we put ourselves in the switch in progress state. And then we say that the requested tab is the one that we've just asked for. We get the browser for the tab that we're asking to switch to. We QI it to a frame loader owner and get its frame loader. We get to its tab parent, and then we see whether or not we've suppressed the tab parent's display port. And if not, then we suppress it, and we add the tab parent to the suppressed display ports. Okay. What does suppressed display port do? No, nothing. Suppress. Underscore P. Case sensitive. During interactions where painting performance is more important than scrolling, we may temporarily suppress the display port. Each enable called must be matched with a disable call. I see. And I think that's to take advantage of making sure that APZ doesn't burn us, because I think whenever you're painting tab content, if it's a long page, we'll end up painting the whole thing, I think, or requesting the frames for the whole like vertical, because APZ wants to know about it, so it can. I think that's the way it is, and this suppressing makes us so that we don't do it and we just render the stuff that's necessary. Then we do the things called pre-actions. Pre-actions. This is the part that always got me. These pre-actions, post-actions things. I never fully understood them. This function runs before every event. It fixes up the state to account for closed tabs. So it's kind of this like catch-all for before the the tab switcher does something, we do these things, then we do the post action. So we're always doing these sorts of things. We do these assertions. We make sure that the switcher is still around, and then we are the switcher. And then we go through the tabs that we are holding on to in tab state. And if none of the tabs have a linked browser, then we delete the tab. Or if any tab doesn't have a linked browser, then we delete the tab. That can occur, I guess, in the event that the tab has been closed while we're switching tabs. Okay. If this last visible tab is not equal to the last visible tab linked browser. Oh, wait. If this last visible tab and not, there's no linked browser, then the last visible tab is null. So the last visible tab was closed, I guess. If there's a spinner tab, so it's the tab that we're showing the delayed spinner on, and there is no spinner tab linked browser, then the spinner tab has been hidden. And we set the spinner tab to null. That's okay, the event that the spinner tab has been closed. And if loading tab and not loading tab linked browser, then we say that the loading tab is null. We clear the timeout on the load timer. We say the load timer is null. Okay. Fair enough. And that's when we requested the tab. Then we clear the timeout on the unload timer. And then we set a new unload timer. And then we do the post actions. And what are the post actions? Post actions. This code runs after we've responded to an event or requested a new tab. It's expected that we've already updated all the principal state variables. This function takes care of updating any auxiliary state. Once we finish loading tab, we null it out. So the state should always be loading. So we make sure that either there's no loading tab or the state of the currently loading tab is loading. Okay. We guarantee that loading tab is non-null if and only if the load timer is non-null. So the timer is set only when we're loading something. Okay. Assert that no load timer or we have a loading tab. Also assert that there's no loading tab or there's a load timer. Oh, load timer. Oh, this is interesting. Interesting logic, but I understand it. This is basically exclusive OR. Exclusive OR. Okay. How do you do XOR in JavaScript? Actually, there's that spinner. Logical operators. XOR. Nothing exclusive? Nothing. No XOR, at least unless you're doing bitwise stuff. Unless I'm wrong. If you know how to do XOR, let me know. Okay. If we're not loading anything, try loading the requested tab. So if we don't have a load timer and the tab state of the requested tab is unloaded, then we want to load the requested tab. What does load requested tab do? Load requested tab will make sure that there's no load timer. We'll say that the loading tab is the requested tab. Loading tab can be non-null here if we timed out loading the current tab. In that case, we just overwrite with a different tab. It's had its chance. Okay. We set the tab state of the requested tab to loading, and then we have an onload timeout. We also made sure that there was no load timer. Okay. See how many tabs still have work to do. So we go and check all of the tabs still in tab state. We check to see if any are loaded and it's not the requested tab, and we also see which ones are loading or unloading, and then we increase num pending, so we have all this sort of in-flight work, or if the state of the tab is loaded and the tab is not equal to the requested tab. So you could be loaded, loading, or unloaded, and if you're loaded and you're not the requested tab, then we're probably going to request that you unload. That's probably what's going to go on. Or after a timeout, we'll ask you to unload. We update the display now. And I think this part's pretty important. Update display. This is what the user is going to see. This is so complicated. The function is called after all the main state changes to make sure we display the right tab. Figure out which tab we actually want visible right now. So get the tab state of the requested tab. If it's not state loaded and the last visible tab and if we have the last visible tab and the last load timer, and we have a load timer, then we're still in the midst of loading this tab and we haven't gotten the frame yet. So we'll show the last tab. Otherwise, show the requested tab. If it's not available, we'll show the spinner. Okay. Show or hide the spinner as needed. So we check to see what the state of the tab is. If it's not loaded, and if we don't need the spinner and there's already a spinner tab, hide the spinner. Spinner hidden. What does spinner hidden do? We'll make sure that there's a spinner tab. We'll log the spinner hidden time. We add markers and we maybe finish the tab switch, which will check to see if there's a switch in progress and the requested tab and the get tab state of the requested tab is loaded. If that's the case, then we can say that the tab switch has been completed and we take ourselves out of the switch in progress. Okay. Else, okay, so we hid the spinner and then we remove the pending paint attribute. And we remove the pending paint attribute on these things so that we don't have weird appearance for the spinner. And we say that the spinner tab is null. Otherwise, we need the spinner. So if we have a spinner tab, then we remove the pending paint attribute on it. Oh, pending paint. What is pending paint? We make it transparent. Okay. Remove the transparency on it. And otherwise, we set pending paint to true and we do a transparency. This spinner tab. Oh, the old spinner tab will make it. If spinner tab. What? We'll remove attribute pending paint, which makes it transparent. Oh, because the spinner's shown underneath it. I see. So we get rid of the pending paint attribute. Spinner displayed. What is spinner displayed again? I think I already saw this, but just make sure that there's no spinner tab. We should start the stopwatch and add the marker. Set the new spinner tab to the show tab, and then we set the pending paint to true on the tab browser to show the spinner, and we set the pending paint to true on the linked browser to make it transparent. Then we switch to the tab we decided to make visible. If visible tab is not equal to the show tab, then we set visible tab to the show tab. And then maybe visible tabs. We add the show tab to the maybe visible tabs. Oh boy, this is so complicated. We get all of these things, the tabs, the tab panel, there's the panel to show, I guess, the tab panel to show. We get the index inside the tab panels for the panel to show. Oh, and then we actually flip. Okay. We actually show the panel. This is us actually doing the panel showing because we're able to show the visible tab now. Then we do adjust focus after tab switch, which that'll update the focus, the user's focus. This doesn't necessarily exist if we're a new window, haven't switched tabs yet. If we had a last visible tab, then we'll get rid of visually selected on the last tab, and we set visually selected to true. Okay. Okay. That's complicated. That's very complicated. Update display. That's in post actions. It's possible for update display to trigger one of our own event handlers, which may cause finish to already have been called. Check for that before calling finish again. If we've gotten rid of the switcher, then we just get out of here. If the num pending is done, then we're done. We just finish. And then we log state that we're done. The post actions. Okay, so that's like the main, those are the main guts of it. And then we have all these event handlers. We have all this like debugging stuff down here, logging and debugging, but the main part after that is the event handlers. And I think what I'm gonna do, it's 2:12 right now. I think I'm gonna pause on this. So where we got to, explored, explained, whoop, why we need the async tab switcher, read through the big comment, went through init, request tab, pre-actions, post-actions, and then update display and all of their dependents. Still to do, all of the event handlers, unloading, etc. Okay, maybe we'll check that out next week. And we will finish off our segment on Better Know a Gecko, learning about the async tab switcher. And hopefully at the end we can maybe write up some observations or maybe some things that we could file to make it better if we've noticed anything at the end. All right, I'm going to cap that there. What are we going to do next? It is 2:13. Let's see. Yay, first Better Know a Gecko. What do I want to do now? I guess it's too early to see whether or not these try results have come in yet, right? Okay, we've got the tests are running. That's good. What's this Moki test push? What does that mean? What is a Moki test push? That took 3 minutes. Don't understand. All right. What's next? I want to. So this is blocked on a try build. What's the link to the try build? I did all this stuff. Boom. Boom. Move the implementation. Did that. Hook up Moz build stuff. Boom. Yes. Done. Yes. Yes, they do. I'm pretty sure. Try build. And now this is blocked on a try build. Whoop. Now what do I want to do? This thing. Where are we? Well, you know what? We're in a bit of a mess because where I am, first of all, I'm way down here in this tree. Second of all, it's like I've got this really weird arrangement of patches that I really want to clean up. Some of these things are like these little one-off experiments I was doing. I kind of want a collection. I want to know which of these I actually want to keep, which are part of the fix, which are part of the of my experiments. I suspect. Let's look at these one at a time. So I'm gonna. This is good. I'm gonna copy. This is handy. I'm gonna paste this as monospace. Whoop, nope. Actually, hold on. Whoop. Mono. Aren't you supposed to be Andel Mono? That's more like it. Okay. So which of these do we want to keep? So let's look at this first one. I think we needed this so that page loader record time. Who uses that? Sensing message, TP record time. Yeah, I think we want that still. Okay. So keep here. I need my old font back. Keepers. They're keepers, but they probably... Oh, and there's other stuff to this. Hang on. Content listener. True. Force tart to run without shims. Okay. Why would we do this? This is so silly. This is sending a kapow message. Why did I do this? Maybe it was simpler. Calling TP record time, which is just going to send a sync message up to the parent. Ugh. Okay, so keepers, but holy smokes. Why are we calling... This is just going to send a sync message back up to the parent. Okay, so that needs cleaning up. But I think that's a keeper. What else do we have here? Add this. I know we want to keep. Oh, that we wrote, I think, during a Joy of Coding episode. Add profiler markers at key points. That's not even... What? No. I don't think we want to keep that. No, we don't want to keep that. Toss out. Don't need that. Then we have... What else do we have? We have add 10-second rest between tart tests. Oh, I remember. I'm going to toss that out as well. Make tresize dump multi-process profiles. We might want to keep that. Oh no, we don't. This isn't even using our good stuff. We should probably make it use our good stuff. Because tresize runs in the parent process, and we had this other thing that I wanted to do where like a profiler parent module for scripts that are controlled strictly in the parent. Okay. So I don't want to keep this. So I'm going to say don't keep. Toss out. I'm going to toss that. What else? What a junkyard. Disable the sync browser init message. I don't think we want to keep that for now. I think that is a problem for other reasons, but it's not part of this. That was like a speculative fix for a regression. 2 runs of tart with boosted exit profiles and faster sampling rate. No, I don't think we want that. So many speculative fixes. 2 runs of tart, and there's another one. It's the same thing. That's just sloppy. So we're going to toss that out as well. A lot of these we can get rid of, it turns out. And then we have run the tart sequence only twice. No, don't need it. So really the only keepers we have are these 2. Maybe. Okay, that's useful information. So I'm going to extract. Well, what is this one again? HT export. That's making. Wait, no. That was the one that was the whip, and then this one is just making tart not use the shims. Or not use shims. You know what? That might actually be a separate bug. Maybe spin this out to separate bug. This is the important one. The rest of these are garbage, and I think I can prune them off. So here's what I'm going to do. I can prune these 2. I'll prune this one. Prune this. So I'll start by pruning these 2. Prune R, that to that, don't need it. Then I'm going to prune this to this. Prune R, that to profile subprocess lifetime, because that somehow had the bookmark. Then we have this one, disable that. Oh, key markers, I can get rid of that. Prune. For change sets pruned. Ruh-roh. That was not according to plan. Subprocess. Oh, right. Okay, well I want to get rid of that one anyways, so I can prune this one. And then I'll prune 31925. Then I'm going to bookmark 319923 as no shim tart. I have to say that that's the revision number. And I'm going to rename, I'm going to bookmark, I'm going to delete profile subprocess lifetime. Instead, I'm going to call it bookmark R319924 Talos E10S profiles. Okay. Now I'm going to rebase Talos E10S profiles onto Central. And I'll actually separate the two because they seem to, there's this like reliance on them. Like one's, I'm going to rebase again, Talos E10S profiles dash Central, so not dash B. So this I'm going to rebase on top of Central. So now I'll have 3 heads. Okay, so that's what I wanted to do. That's good. And now I will build. And in the meantime, we can take a look at what sort of things we want to change. And what kind of improvements we want to make. I don't think we'll have a whole lot of time today. We've done a lot of like exploration and maintenance. You know, if I'd thought this through a bit more, we could have written more code. Need a little spinach. Excuse me. But I wanted to do that exploration. I wanted to try that get to know better know a gecko thing. So what did I want to do with this profiler thing? Under Talos, testing, Talos. It was under Talos Powers, I think I gave it the Talos Powers service for that profiler.js. Here we go. Content mark. Right. Marker to the profile in the content process. Add a marker to the profile on the content process. Samples. This occurs synchronously. Okay. Great. Trailing comma. Now what else did I want to do? Write a profiler parent JSM for the parent. Okay. Hang on. Var profiler. I wonder if this should be a class. That's what I'm thinking. Because right now it's this like object that has state in it, and I wonder if like instead of keeping it around, you should be able to instantiate it in the test, use it, and then chuck it away. I wonder if that'd be a better interface. Let's not worry about it. But you know what I do want to do is make sure that we call it specifically that this is a content profiler. Talos content profiler. Anything else? Profiler settings. Or maybe I'll just call it Talos profiler. Well, Talos content profiler. I'll stick with it. Let's make it explicit. Talos content profiler. Okay, so now we have this content profiler thing. And then maybe what I'll do is I'll even make it more I'll make it even more explicit, and I'll call it content profiler. HGMove, testing, Talos powers, components, no, content. To powers, content, Talos content profiler. .js. Hey. All right. So anything that wants to use it needs to use Talos content profiler, and then in the parent, Talos parent profiler. That's what I'll use. But that one I think we'll need to like create instances of. Maybe I'll even alter this so that it's like, yeah, you instantiate it. Okay. Well, for now, I'm going to create a new folder called modules. I'll call a new file in here. We'll save it as Talos parent profiler. You know, I will also update the documentation. This utility script is for instrumenting your Talos test for profiling, performance profiles, while running in the content process. This will also work if you're, while running within, I shouldn't say content process, running within content. If your test is running in content, okay. If your test is running in the parent process, you should use Talos parent profiler.jsm instead to avoid the messaging overhead. Okay. It's Talos Parent Profiler. License. Use strict. Nope. And then this dot exported symbols equals Talos Parent Profiler. Okay. Let Talos Parent Profiler. I'm going to say it's going to be a class. Function Talos Parent Profiler. Talos Parent Profiler dot prototype. I actually think I can probably use like ECMAScript, like 6 classes. I'm pretty sure I can do like class Talos Parent Profiler stuff now, but like it's possible that we'd want to run these new Talos tests against old builds, so maybe I shouldn't. Oh, it's late. It's 2:36, folks. I'm going overtime here. I'm sorry. Holy smokes, where'd we get to? Let's take a look at the agenda. Okay, so we cleaned up this patch and we put it up for review. I'm waiting for tests to come in. Let's see how they're doing. Was this it? This may have been it. Okay, so we've got some failures still. That's not amazing. What? No. I thought I'd fix this. Alright, I have to figure out that bit. And I don't know why that's not working. That's annoying. Package. I'm certain, didn't I update package or installer? What? I could have sworn I updated the patch to use that installer thing. What? Because I remember there was this thing I needed to do. Did I not commit it somehow? Where is it? Where is the code? Standard. Like added this thing to. Wow. I didn't add it. I'm gonna have to push it again. Shoot. Okay, well, I'm glad I did a try push. Okay, so cleaned up some stuff in there. Still some work to do, but you get the idea. I did this new segment called Better Know a Gecko, where we're just sort of exploring and clambering through a complex piece of code. I try and understand it at the same time as you. I don't know what you thought of it. Let me know. Let me know, because you can now rate this episode and you can give me feedback directly, or you can tweet at me or ping me an IRC or find my email address and email me and let me know what you thought of that segment, whether or not I should do it more. I don't know if I'll do it next week. Let me know. Let me know if you liked it. And then we started working on this profile dumping stuff and basically just sort of cleaned up my patches, figured out what I don't want, pruned a bunch of stuff, and then we got ourselves sort of ready to write the parent profiler thing, Talos Parent Profiler. Did you know that you can subscribe to this podcast? This isn't a podcast. You can subscribe to this video series using your iTunes or your Kodi or any kind of media streamer that allows you to subscribe to RSS feeds. You can totally do that. And there's a link here in my agenda that allows you to do that. If you are part of the Mozilla community, I encourage you to start live hacking. Contact me, contact M. Conley or Richard Miliuski. You can find us in Hash Live Hacking, and we can tell you what you need to do in order to get set up to start live hacking, get your own show going. It doesn't have to look like this. It could just be, it could be anything. It could be you typing. Joel Marr does one where he sheriffs Talos regressions, and you watch him like deal with Talos regressions. I've seen one from Sean Martel where he's got his joy of illustrating, where he just breaks down logos. Like he broke down the Firefox logo and shows you like all the parts to it and like how it works. So you should check that out. I think I'm pretty much done here. Again, please, 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 please rate this episode and comment and let me know what you think so I can make this show better for you. I want to make it the best it can be. I really appreciate you doing that. Give me your honest feedback. That's what I want. I want to know your honest feedback. Okay. Thank you so much for watching episode 40 of The Joy of Coding. 40 episodes! Holy smokes. The Joy of Coding is almost middle-aged in terms of episode number. I wonder if our midlife crisis occurs. Well, that assumes that there are only going to be like 100 or so episodes, which is not the case. I'm going to keep going until someone stops me or no one wants to watch anymore. So here's to the next 40. Here's to 200. Here's to 500 episodes of The Joy of Coding. We'll keep it going. And I'll see you next week. Take care. Bye-bye.
The joy of coding.
See ya.